So now we're back at this worksheet and we're going to do the next part on this worksheet, which is identify all the functional groups in each of the following molecules. And so hopefully you have somewhere handy the table of functional groups that I showed you in the lecture for section 11.5. I'm going to have to do it by memory, but you can always do this by referencing those tables, those 3 tables of functional groups that you have in your textbook. Now, when we're looking for functional groups in a molecule, I'm going to start by saying that almost all, maybe all, probably okay to say all of the molecules that we are going to be looking at, they all have the boring alkane functional group. The alkane functional group is where we have carbon-carbon single bonds. That's a pretty boring functional group. Chemists in general don't count alkanes when they're counting up functional groups because they're everywhere and they're not that interesting. So when you're being asked to find the functional groups in a molecule, that means you can go ahead and leave out the alkanes because they're just not that interesting. So we're looking for something other than alkanes. And what you want to look for is basically anything that isn't just plain old line structure. So you're looking for atoms like oxygen. When you see oxygen, you know that that's got to be a part of a functional group. Oxygens and nitrogens and halogens are always part of a functional group. Once you find that atom, or atoms in this case, then you just need to look at your table of functional groups and try to match it up with what you see in your table. This is the carboxylic acid functional group. Now you might be saying to yourself, oh, isn't the OH, isn't OH an alcohol? Is that an alcohol? And the answer to that is no, it's actually not. Yes, OH is an alcohol. Ooh, I erased too much. OH is an alcohol, but when the OH is attached to the carbon-oxygen double bond, it's a carboxylic acid, not an alcohol. An alcohol is an OH that is attached to anything other than carbon-oxygen double bond. So here's another functional group. If you see carbon-carbon double bonds or carbon-carbon single bonds, triple bonds, double bonds or triple bonds, that's a functional group as well. This is the aromatic functional group. And that's all that this molecule has. Looking at vitamin A, I see double bonds. Double bonds are definitely a functional group, and all of these double bonds are the alkene functional group. Now again, you might be asking yourself, wait a minute, there's a 6-membered ring here with a double bond in it. Isn't that aromatic? Isn't that the aromatic functional group? And the answer is no, it's not. In order to be an aromatic functional group, you need to not just have a 6-membered ring, but have alternating double single bonds like we saw in the ibuprofen molecule. So it's not just the 6-membered ring, it's also the alternating bonds. And then over here we have an oxygen, and this is an oxygen that's not attached to anything interesting, so that makes this one an alcohol. Oxygen that's just attached to the molecule, doesn't have anything interesting attached to it. Let's look at THC. So we can see we've got some atoms that are not carbons and hydrogens. There's one right there, that's going to be something. Here's one right here, that's going to be something. Plus we've got a double bond over here, that's something. And then we've got the 6-membered ring, alternating double single bonds, that's something as well. So we've got 4 functional groups in this molecule. Let's start with this one because we've seen this one already. This is the aromatic ring, the 6-membered ring with alternating double single bonds. We have an OH. It's written backwards, HO, but we can write molecules forwards or backwards in organic chemistry. So OH and HO mean the same thing, and that's an OH that's attached to just a regular carbon, so it's an alcohol. We have a carbon-carbon double bond, which is an alkene. And here we have a new one. This is an oxygen, not an OH, not part of a double bond. This is an ether. Let's look at L-DOPA. Let's just start by finding all of our functional groups. We've got oxygen here, we have a nitrogen down here, and then we have these oxygens right here. Oh, and we have carbon-carbon double bonds. There's a lot of aromatic rings in organic chemistry. This pattern we've already seen once in ibuprofen. This is the carboxylic acid. And these are OHs, not attached to a carbon-oxygen double bond, so those are alcohols. And then here is one we haven't seen yet, a nitrogen. Whether it has 2 hydrogens or 1 hydrogen or no hydrogens, that's an amine. Let's take a look down here. Our next one is fluoxetine. We've got a halogen right there. We've got some double bonds. We have an oxygen and we have a nitrogen. The rings, you're definitely going to be recognizing those by now. So that's our aromatic. We have another oxygen, not an OH, not a part of a double bond, so that's an ether. We saw that one already in THC. Here's a nitrogen, that's an amine. This one only has 1 hydrogen on it. And then over here we have a halogen, we have fluorine. So we call that the alkyl halide. And then last but not least, we have cocaine. We have a nitrogen. We've got an aromatic ring. You're definitely going to recognize those now. And then we have these 2 oxygen looking things right there. So let's start with the easy one, the aromatic ring. And over here we have a nitrogen. This nitrogen has no hydrogens on it, but it doesn't matter. It's still an amine. And then we have these 2 groups. So this is new. We have a carbon-oxygen double bond with an oxygen. We've seen a couple that kind of looked similar, like right here, carboxylic acid. But this is not a carboxylic acid. It doesn't have an OH. This is a different functional group called an ester. So again, all that you really need to be able to do is look at these molecules and match them up, match the functional groups up with the table that you have in your book. You don't have to memorize any of them.